Aggregate functions turn heaps of data into meaningful numbers. Hi, I'm Philip from codekabinett.com, and today I would like to talk about aggregate functions in Microsoft Access. Well, aggregate functions aggregate data, and I think what exactly that means becomes clear if we talk about the functions that are built into Access in more detail. There are actually 7 built-in aggregate functions in Microsoft Access, and they are pretty much standard not only in Access but in basically any SQL-based database engine. So let's start with the first one. It's pretty easy. It's count. With a count function you can count the number of records in a query or in a table, obviously, and you can use criteria to reduce the number of records and count only those that match specific criteria. And you can either count one distinct field and you count distinct values, or you can count simply all of the records. So no matter how many records are in your table or in your query, there will be only one line returned by the count function, and it will be a number, obviously. And that applies to whole records. It's counting records or unique values. So the input can be basically any table or any column. Then there are the functions min and max. They return the minimum or the maximum of a particular value in a column. And that is not limited to numbers. You can also calculate the minimum of a text field or a date. No matter what, it will use the sort order of your database to get the lowest value or the highest value if you use the max function. The next one is sum. Simple, it sums up data, and that does only work with numbers, obviously. You cannot sum up strings in a meaningful way or dates, so only numbers here. And the same goes for the next function, average, or AVG in short. That calculates the average of a numeric value in a column. And once again, you can always limit that down by using additional criteria in your query to reduce the number of records that average or sum or whatever is calculated on. Then there are 2 functions of statistical calculations. It's the standard def function and the var function, and these are useful for statistical purposes if you want to determine the standard deviation over a number of records or the variance in a number of records. I'm not going to cover these in detail because I do not have the statistical backgrounds in my mind present right now to properly cover them. And then there are 2 more functions. Yeah, I said there are 7. There are 2 more functions that you should not use. And that is the first and last functions. And you might think they return the first value or the last value in a particular column. But by which sort order? And that is a bit of the problem why you should not use them. Now, Microsoft acknowledged the fact that these names are pretty confusing and will cause problems. Originally they said, yeah, you get the first or the last value in a set of records, and that is correct, but it is the first value or the last value that the database engine encounters while processing these records. And it's almost impossible for you to know which record that will be. So do not use first and last aggregate functions. They return a random value. You can use them if you say you need just any value and you do not care which one it is. But in all other cases, do not use first and last. So, one important thing we need to talk about when talking about aggregate functions is the group by clause. You will always or almost always combine an aggregate function with a group level, like you calculate the total value of orders, that's an example we are looking at soon, for one customer. Then you would group by the customer, by its name or ID, and then use the aggregate function sum to get the sum of all his orders, all the order values. So you need to always consider, when using aggregate functions combined with distinct values from your data, you need to apply the group by to all other values that you want to output in your query. Now, there are some helper functions built into Access, the domain aggregate functions. These start with a D, like dmax, dcount, dsum, and you can use these easily in expressions like in forms or in your VBA code or even in queries, and I'll show an example for that later. And they work basically the same way as the aggregate functions work. You put in a column name, a table or query name, and optionally the criteria, and then the function will get the count of records in that query or table matching the criteria, or it will sum up the sum of numeric values in a table matching your criteria. Pretty simple, but also a little bit limited compared to the real aggregate functions in queries, because you always get one value as output. That is desirable if you put that into a control in a form, because then you can only display one value. But if you want to calculate these aggregated values for any number of records, it is not as convenient, and they have a bit of performance problem when used in that scenario. So they basically work very similar. If you understand one, you probably understand the other, but you need to know which to use when. Okay, well, one more remark. I did on that the first and the last problem, I did a very extensive text. I'll put the link to that in the video description. And now, without much further ado, we look at the screen and look at a couple of examples. And here's a table TBL customer, and maybe you have seen that in the previous demos. It's a very simplified table, and there are several things in there that are not good practices. So just as a side note, if you see something in my videos and that is not the core topic of the video dealing with that, it might have been that I used some sort of simplification to make the sample easier to comprehend, and it's not necessarily best practice to do things that way. And that is actually something, or a detail of that, we are going to put right today. Here are two columns, total order value and last order time. These are two columns that contain additional information to customers, but there is a major problem with them, obviously. They need to be maintained manually, and that is always a problem. You see it down here. These area, they are not really maintained in for recent records, and the top records here are probably wrong. In this database that is used to record customer orders and process them, it would be easy to derive these two columns from the data actually entered into the database and use that instead of these manually maintained columns. And that's what we are going to do. We are building a query as customer overview to derive these information from the records in the database. First, let's look at the tables in this database. There are only 4 tables, but they already contain a bit of complexity, but that is something that you are most likely going to see in a real-world database application if it is properly normalized. We just looked at the table customer. Now let's look at the orders, and there's not too much in here. It's the order ID as a primary key. It's the customer ID referencing the customer, an order date, and the order status. Not much more. So it does not contain the data we need to calculate the total order value. For that reason, we need to go one level deeper, and that is the table order position. And that references the order and has a position. These two actually are combined into the primary key. Then there is an item ID and a quantity. And even that does not allow me to calculate the order value. I need to go one level deeper and include the items. And here are a couple of grocery items with a net price in here. So I need all 4 tables to kind of build my customer overview. So I'm going to use a divide and conquer approach to get to the final target of the customer overview query. So I create a simple helper query first. I go to create, query design, and then I add these 3 tables to my query. And I usually order the queries from left to right in their hierarchical relevance. That is the order position, and finally the items. Now I need all 4 columns from the order table to create an order value query, and that is what I'm going to do here. I just want to calculate the value of an order and kind of eliminate these 2 lower level tables from the equation. So I need all the order fields, I got them already, and then I'm going to need the quantity and the net price of the items. And well, we leave them in here and add another column to do a simple calculation here. It is quantity times net price. And I just run that. So you see we've got the quantity here, the net price here, and that is the extended price of this order position. If I sort this by the order ID, you see these 4 rows are the order positions of the order number 1. And what I actually want to do, and I go back to design view, is to calculate the sum of the order value for the whole order. I go here and activate the totals calculation functions, and you see there is a new line in the query here that just appeared, and that allows me to define aggregate functions in my query. For this simple calculations, I want to use the sum aggregate function. So you see I can choose all the aggregate functions like sum, average, min, max, and so on that I previously mentioned. And the group by is simply the grouping level. in this case, I want to group by the 4 columns from the order table and use the aggregate functions only on this expression here. So I just choose sum here and define a meaningful name. That is always very important. Use meaningful names for your fields, for expressions, that you do not use that expression 1 that access defaults to. So this is the calculation, and I want the sum of the results in the final row. And I'm going to make a mistake here just to show that. I run that, and you see there are still 4 records here for the first order. And that is because I still included the quantity and the net price as grouping levels. And that is wrong because they are different for each order position. So I need to get rid of them from my query. Just mark them and hit delete, and they are gone. And now I run this query again, and you see there's only 1 row left for order 1, and that is the total value of this single order. That is what I want to achieve. But before we close this and move on, I'm going to show you how to use a where condition to filter the data. If we don't want to see all orders, but only the orders that are completed, I can change this to a where condition and say we only want to see completed orders. Now the query runs, and it still shows only the data for the order, for records, and the sum of the details, but the orders are filtered now by this criteria. Okay, I do not want to filter this query in my customer overview, so I change that back to a group by and include it in the output. So just a minor detail, pay attention to my calculation here. There's going to happen something now when I save this, close the query. Yes, I want to save it as query order value. I close it, and now I open that again, and you see Access changed this to be an expression now, because it is not a real column but a calculation, and it put the sum aggregate function inside this expression. That is valid as well to write it this way, and the result will stay exactly the same. But you need to be aware that even though this is an expression now, it still can contain the aggregate function up here. Now this was only the first part of our customer overview. Now we are creating the real customer overview. I go to query design again, and now I only add the customers table, then go here to queries and add the order value query we just created. These two are already linked via the customer ID, and now I can add the fields down here. I just need the customer name for now, and from this table I am going to need the order date, and I'm going to add it twice, and we should add the order value, of course. And we can add the order ID. And that seems to make not too much sense, but now I'm going to enable the calculations via the totals. And now we can do a couple of nice things here. I use the minimum of order date, and that will give me the first time or the first date the customer ordered with us. And then I go to the second order date column in here and I say, yeah, I want the maximum, the last date of the order. For the order value, I once again add the sum here. So I get the total value of all the customers' orders. And I can add one more thing, which might be interesting in the context of a customer overview. I can count the order IDs to see the number of orders a customer placed with us. And there is even one more column that might be interesting to us. I drag down the order value once more and I go to the average function down here to see the average value of the customer's orders. So I put that here so that we have sum and average close to each other. And now I can run this query. And you see this nice customer overview, and you see these columns get automatically assigned names, and they are not too bad actually. The min of order date is the first order, max is the last order. This is the total sum of all the orders, and that is the average order value, and this obviously the number of orders the customer placed with us. So if you want to change the column names, you can do that here by defining an alias for these columns. So this is the minimum order. So I say that is the first order date. And this one would be the last order date to be a little bit more meaningful. And if we run that again, you see first order date, last order date. So I'm not doing this for the other columns, but you see how easy it is to define your own column names in there. I close the query and save this as query customer overview. So far this has been the basics of aggregate functions in Access. I want to take this one step further because there's one question that frequently arises after you created such sort of aggregate query. What about getting data from one particular order? Let's assume we want not only show the last order date, that was easy to retrieve, but we want to show the last order status and the last order value in our customer overview. And that is going to be a little bit more difficult, but I'm going to show you how it's going to work. So to retrieve any information about the last order, we need once again to split that up into two queries. We could use a subquery, but that is a topic for another video. So now I'm going to use two queries which you can easily design with a graphical designer. Well, I go to create query designs and just add the order query up here. And I only need the customer ID and the order date because I want to retrieve the maximum order date. I just switch to totals once again and say, yes, we need the maximum of the order date and the customer ID. And this is just what's going to be in this query. I close that and save it as query last order date per customer. And now I'm going to create yet another query, and I only add the last order date per customer and the order value query. And now I can add the customer ID and these columns from the order table, because that's what I wanted to do. I wanted to know the order date, the order status, and the order value of the last order. So what we need to do now is join these two tables, or rather queries here, because Access was not able to do this automatically here. So obviously the customer ID will be linked to the customer ID. And now comes the clever bit. We have the last order date here, the maximum of the order date, and that will be linked to the order date from our query order value. And if I now run this query, you see we only see these few records here. I sort by the customer ID, and this is the last order for each customer. So now I can save this. Last order per customer. So you see the difference. I named this query last order date per customer because it contained only the date, and this one last order because it contains the full order information, including status and order value. And finally, I can go back to my customer overview query, open that in design view, and add the new query we just created, last order per customer, and this will be joined via the customer ID, and then I can add the order status and order value. And now I should definitely add a more meaningful alias here. So this is the last order status, and this is the last order value. So it's not so easy to see here. I scroll a bit to the side. And they are both group by columns because they are already aggregated on the customer level. So I just include them in the group by column list. So I run this query, and we make this a little bit smaller. Now you see this is our last order value, and that is the last order status. I did not include the last order date from this query because we got this here already. We could have, of course, created another query based on top of the customer overview because that contained the last order date. That would have also worked to kind of avoid the additional helper query I created. But nevertheless, I think this way is more structured, so I choose it that way, but in the end it would not make much of a difference. To wrap things up, let me show you a problem with the aggregate functions. They are obviously in many cases read-only, because if you aggregate a sum of something, you cannot change the value of that sum by editing the data in the query, because the sum is calculated from any number of detail records. So, but let's look at the last order per customer. Oh, and this is an interesting problem. A small detour here. That is not what I wanted to show, but I'm not going to cut this out because this is a problem that frequently happens. I am asked by Access to enter a parameter value for query 1 customer ID. And you would say, this is insane. There is no query 1 nowhere to be seen. So this is pure nonsense. And it is, but I show you how this problem came into existence and how to fix it. So if I just cancel that, you see my query is empty, and that is obviously not really what's it supposed to be. So I go to design view, and once again you see there is no query 1 anywhere to be seen. But I show you where it is. I go to the property sheet here, and now I click into the gray area here to get the properties of the queries, not the individual columns. And now you see it here. This is causing the problem. This is the order by I kind of created when sorting the query in design view. And while I was designing the query, it was not saved, and Access defaulted to the name query1 to address this query. And when I saved the query, it still had that order by expression in here, but referring to query1. And while saving the query, I named it query last order per customer, but that did not change the order by expression in here. So this does not work anymore. And so the easiest way to deal with that is just delete it. We just save this, close the query and run it again. And you see now it works. But actually I wanted to show you something else. This table, or rather query, shows the last order per customer. So this is a distinct order record, and this should be editable. I should be able to go in here and go to that order and write completed in here, but it does not work. You see over here, this record set is not updatable. And that is an annoying thing that Access does, because there is this aggregate query in there. Access makes the whole query read-only, even though the records from query order value should be updatable because they just reflect single records from the order table. That is massively annoying, but I'm afraid there is no way around that. Well, I said there's no way around that, but there is, with a small trick. And now that is where the domain aggregate functions come into play I mentioned earlier. So as a short interlude, I would like to show you how to use the domain aggregate functions. And the difference domain is going to become very clear. We go to the Visual Basic environment. And now I just use the immediate pane down here. You can activate that. Your environment will probably look like that. And if you go to the View menu, you can enable the immediate window here, or just use the Ctrl-G keyboard shortcut. Now I can type in here and got the decount function here, and the first is an expression, and for count this can be the star, but it is a string argument as you see down here, so we need to enclose that in quotes. Then we need to add the table name here, and we can use criteria. Let's call it this way. So we got 33 orders in total, and I can easily restrict that to the orders of one particular customer. So I write customer ID equals and just choose customer 8, and now this customer has 8 orders, While when I change that to customer ID equals 1, then the customer 1 has only 4 orders. And I can use that with all other domain aggregate functions, but if I use dmax, I need to specify a column name here like order date, and that is the maximum of the order dates for customer 1. If I change that back to customer ID equals 8, then I get the last order date for customer 8. And now you can just use this expression right inside an access form. Quickly do that here. I design a new form and just enter a text box control in here, and I go right to the control source of the control, go to the zoom window, paste that here, and I need to change, in my particular case, I need to change the separator here to the semicolon, but that is because I've got German language settings on my PC. You will most likely leave the comma in there to make it work. And I need to put the equal sign here at the beginning to signal to Access that this is an expression in the control source that should be evaluated. If I now switch to the form view, you see this is the last order date for the customer. And so you can use the domain aggregate functions in your forms as well. So I said there is no way around that, but that's not entirely true, because there is. But you need to know how it works. I create yet another query and I just add the table order in there and close that. And once again, I take all 4 columns from the table, pull that down here, and now I need to add a criteria in here. We need the last order date, and there is another way to get the last order date, and that are the domain aggregate functions, and more specifically the dmax function. So in the criteria section down here, I enter dmax. And now it gets a bit complicated because we need to query for the order date, and that is going to be a string. So I enclose that in quotes. And let me go to the zoom window here and increase the font size so that you can see this better. So we enter order date because we reference the order date column, but that is a string expression, as I said. Then we need to reference the table, and it is table order. And once again, this is a string expression, so I enclose it in quotes. And finally, we add a criteria in here as the third argument to the dmax function, and that is the customer ID equals, and now it gets even more tricky. I close the string here, and now I concatenate that with the customer ID from our orders table that we are using as the data source for the main query. And now I do not want to reference customer ID as a string, but I want to retrieve the value of the customer ID. So I enclose this in square brackets to signal to Access that this is a reference to a column, and I rather want the value instead of that name. So I confirm that with OK, and we should be good to go to run this. And you see, we got this query here, the new query 1. Then put this over here. Now this is the original query with the aggregate functions, and you see, so it contains the same data, but let me reorder the columns here so that you see that. And once again, you see it's all the same data. We don't have the order ID in the other query, but it's all the same records. And this query I created with the dmax function that is actually updatable. So I can write in here completed. That is the difference in using the function, because this function expression does not make the query read-only. It is still updatable. So I save that as query last order per customer, and I say it's editable. So the advantage of this type of approach is clear. The query is updatable. Nevertheless, I would only use this if you definitely need an updatable query. For all sorts of reports and read-only forms where you only display information, I would prefer the approach with the aggregate functions, the real SQL aggregate functions I showed you earlier, because that is usually much faster. And there used to be a couple of problems with these domain aggregate functions if they were used on a huge number of records. And this function is called for each record. It is not a big deal here because we only got 12 different records. That's not much. But if you got a large customer base, like thousands of customers, the function will be invoked for each record, and that might slow the whole operation down quite a bit. And it might cause some memory issues. In previous versions of Access, it might happen that you get an error like no more, there cannot be more databases opened or stuff. And that was actually caused by using such domain aggregate functions in this way on a large number of records. I haven't seen that in a while, so I guess Microsoft fixed the hard errors, but nevertheless I would still recommend to use the SQL aggregate functions whenever possible. Okay, that were the samples. You see, it's pretty easy to deal with those aggregate functions in Access, and I only used the graphical query designer. I was not even I did not even need to resort to SQL. You can do that all with the query designer in Access. And that is something where you should notice how much more convenient it is to have a database where you can define such calculations compared to an Excel sheet where it is much more tedious to constantly update that when you enter new records into your Excel sheet. Then it's all much more of a flow. In Access you define it once, and that is something that I might have shown a bit more. You define all these aggregate queries once, then you enter new customers, new orders into the database, and then you run the aggregate queries I showed you again, and they will automatically reflect all the new data and will be updated with all the new data. Pretty simple, but also pretty powerful, and there's no way around these aggregate functions to really show human meaningful numbers from huge amounts of data. It is not limited if you got 100 customers, 1,000 or hundreds of thousands or even millions. You can apply the same principles there and calculate meaningful numbers for your customers, or even on a higher level for your whole business, like your turnover the last month or things like that, where you condense huge amounts of data into very few meaningful numbers. Okay, thank you. That was everything for today. If you liked the video, please remember to like the video or subscribe to my channel, and thank you for watching. Bye for now.